Woohoo! We are live. This is Math 60. This is section 5.1. We're talking about exponents. This is going to hopefully be pages 3 and 4. And I hope this is review, but if this is not, this may be a bit shocking. And that is following up with what we did on the first couple pages. We have got a definition for what the heck a negative exponent would be. Now, when I say minus n like this, a to the negative n, or a to the opposite of n, which is a better way to say it, we don't know for sure that this is negative. But the point is that if we have the opposite of n here and n here, this is the relationship. So, in other words, if I can sneak it down here, in other words, if I have 5 to the negative 2 or 5 to the opposite of 2, write it big so I can see it too. It means basically, the way that I look at it is there are two places you can be if you're a base. You can be in the numerator or you could be in the denominator. And I know that's what everyone wants. They're like, oh, good, fractions. But that's basically what we're talking about here. And if you've got a sad exponent like this, 5 to the negative 2, that negative 2 is very sad. Let's make it happy. So here's the thing. I had some students many semesters ago. They decided that actually bases that have negative exponents are in fact vampires. They want to be downstairs. They want to be in the basement. It's too sunny up here. They're very sad. Here's another vampire right there. 3 to the negative first power. Not happy. Let's make it happy. Put it in the basement. So happy. Now, once we get it down into the basement, of course, we could simplify. This would be 1 over 25, and this would be 1 over 3. The important point being that a negative exponent tells you you are in the wrong place. Now, what about, and of course, I made these so close together, and now I regret. I have many regrets. What if you've got this poor base down here, 4 to the negative 2, in the basement, not happy? Well, let's make it happy. It's so easy to make numbers happy, seriously. So 4 to the negative 2 in the denominator, it means it's 4 squared. That's 16. It's very happy to be up out in the sun. This is not a vampire. Okay, negative 2 to the negative 2. This is pretty exciting. Negative 2 to the negative 2, or negative second power, or I don't know if you could say negative squared. Seems a little odd. Okay, first thing we're going to deal with is the exponent. The exponent says, ooh, we're a vampire. Okay, that's cool. We'll put it down in the denominator. Now the exponent is happy. Notice it went from a negative 2 to a positive 2. Now I'm going to square this whole negative 2. Negative 2, the quantity squared is 4. Now, this next one, oh man, this next one is enough to give everyone a little bit of pause. So remember, when we don't have, so in other words, negative 2 to the negative 2, when I don't have these parentheses holding the minus and the 2 together, the minus just kind of hangs out and only the 2 goes downstairs. Isn't that a little weird? And then we get negative 1/4. So yet again, we're noticing parentheses end up squaring that minus sign, so we get a positive answer. No parentheses, no squaring of the minus sign, negative answer. Woohoo. So in this next one, I'm going to go back up. And, oh, you can barely see it. So let's read the instructions first, and then I'll push it up. Express using positive exponents and then simplify if possible. In this case, and this is really tiny, so it's kind of hard to see, but I actually have a 12x cubed, and then y is to the negative 6th power, which means you got it, vampire. Who knew? Oh, no. I got to fix this. Oh, you know what? There's no fixing that. I'm just going to scratch it out. What? Look over there. I don't know what happened. Okay, I've got 12x cubed. Y is a vampire. Why? Because we love you. And you end up with y to the 6th in the denominator. See how happy it is? See how sad? happy, sad, happy. Okay. Now, is there anything we can reduce? Nope. So let's move on. Okay, this is a big old pile of pain. So what I'm going to go through is I'm going to look for, well, let me rewrite this. Let's see, a, b to the -3, c to the 4th, all over d to the 5th, f to the -2 or -2nd. So the first step we're supposed to do is express using positive exponents. So a is happy, b is not happy. Put b in the denominator. C, happy. D, happy. F, not happy. F comes up. So everybody who had a negative exponent went to the other spot. So easy peasy. And then we look at this and we see, okay, these are all different variables, so nothing reduces. That's our final form. Okay, how about if I try to make things a little more exciting and I multiply two bases with exponents? Well, the way I'm going to do it, there are a couple of different ways we can do it. You could go ahead and add the exponents because we've got a rule about adding the exponents, or I could even look at it this way. Now, this is interesting. These are kind of twins. One twin is a vampire, the other twin, not a vampire. So the 5 to the -2, let's make it happy. And then there are actually two 5s down here, 4 5s up there. So really, and here's the thing, hundreds of millions of years ago, when they were first inventing exponents, that may be a little bit of an exaggeration, maybe tens of millions of years ago, somebody had to test out this theory that negative exponents referred to things in the denominator. And one of the things that really works nicely is that if I had multiplied these, I would have added the exponents. -2 plus 4 is 2. But if I write them this way and then I subtract because it's division, I also get 5 squared. So there is this beautiful completeness to this. Okay, now what am I doing here? Well, now here's a case where they're twins, but it turns out they're both vampires. The 5 to the 4th is happy being down there, but the 5 to the -2 really unhappy upstairs. So let's bring it down. I got the 5 to the 4th and the 5 squared. Now here's the question. If you bring everybody upstairs or downstairs, who's left? And the answer is, well, with exponents, we're dealing with multiplication. So when you move everybody away from a spot using multiplication or division, you end up with a 1. So I get 1 over 5 to the 6th. And now I'm regretting because now I have to use my calculator. On a calculator, ooh, that giant calculator that swallowed the universe. On a calculator, let me try to get it so it's not shining at everybody. On mine, the exponent key is this little caret. Some calculators have an X to a Y or a box to a box. Okay, let's do 5 to the 6th. Oh my goodness, that is not something I would have memorized. Let's see, 15625. 15,625 in the denominator. Oops, let me pull this up so you guys can see it. Woohoo! Woohoo! So we're at 8 minutes 50 seconds. Let's press on and do the 4th page just because we roll like that. So here's 5.1, the 4th page, and here's the power rule. Sounds like fun, doesn't it? Okay. If I have 3 squared to the 4th power, what does it mean? It means I've got 3 squared written 4 times because it's raised to the 4th power. Or in other words, I've got 3 times 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 3. There are 4 sets of 2 3s. So altogether, there are 8 3s. I'm just going to write 8 there so I don't get confused. Because if I write 8 3s, it's going to look like 83, and I'm not sure how to write that. I could spell one out, but it would require spelling. And this is an English-free sort of, video series. So English department is welcome to teach English on their own time. So I've got 3 to the 8th. So the interesting thing here is I started out with 3 squared to the 4th power, and I ended up with 8. And I'm thinking, how do I get from 2 and 4 to 8? You've got it. You multiply. Now, this is a situation that confuses people a lot. So right above here, because I've got a little bit of space, let me remind you. If I have 3 squared times 3 to the 4th, so I have 2 bases, 2 exponents, and the bases match, then I get 3 to the 2 plus 4, so that's 3 to the 6th. If I have 3 squared to the 4th, let me put in a verses there. If I have, I know I got scared and I got excited actually, and I wrote them too close together. If I have 3 squared to the 4th power, that's when I multiply. So if I've got 2 3s, 2 bases, and 2 exponents, you add. If you've got 1 base and 2 exponents, you multiply. Okay, so that's a hard thing to remember, but it's really worthwhile. This is going to come up quite a lot in math. Okay. Ooh, simplify. What if I've got 2 to the negative 1st to the negative 2nd? What is negative 1 times negative 2? It's just 2. 2 squared is 4. So now what was really happening here? Well, 2 was feeling like a vampire here. And so we had 2 to the negative 1, which is 1/2. Oops, I went right off the side. Sorry about that. 2 to the negative 1st to the negative 2nd, or 2 to the negative 1 to the negative 2nd, or 2. I get 1/2 to the negative 2. And then what's going to happen here? Well, basically, this whole thing, because of that negative, is going to flip over again. So what happened was the first minus flips it upside down, the second minus flips it back right upside again. That's why the 2 minuses cancel each other out. And I feel like I need a visual aid here. I need my 2 minuses coming in. Oh, sorry, that looks like a multiplication. Oh man. This video production thing, this is harder than it looks. Anyway, you get the idea. 2 minuses come in. Oops, wrong figure. And then they make a plus. Woohoo! Okay, next one down. If I've got x to the negative 4 to the 5th power, x to the negative 4 to the 5th power, it's x to the negative 4 times 5, so it's x to the negative 20th. Wow, mega super vampire. We're talking like Blade. If you don't know what that is, go look it up. Ask your grandparents, who are way cooler than I am, I'm sure. 1 over x to the 20th. Okay, next up, and this is the last thing on this page. I know this is very exciting. I'm pretty excited about all this. Powers of products. So in other words, right here, I've got a times b cubed. So let's look at what happens. I've got a times b, a times b, a times b. There are 3 of them. Well, that means I've got AB, 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 which another way to write that is A, B, 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 because we've got something called the commutative property. It says when you're multiplying a bunch of stuff, you can put it in any order you like. Ta-da! Now here's the thing. If you've got an exponent out here, and you're going to say, oh, the A is going to get one of them and B is going to get one of them, it's very, very, very tempting to call it the distributive property. This will literally make math teachers' heads catch on fire, which is just not, it's a safety risk, actually. Because if you look around, most math classrooms do not have fire extinguisher. So you should not be setting your teachers' heads on fire. So please do not refer to this as the distributive property. The way that I usually refer to it is if you know there's a very famous woman named Oprah Winfrey, and for a long time in the late 90s, early 2000s, she was very famous for giving things out. People would come to her show and she'd say, look under your seats, everybody gets a Jeep, or everybody gets a new house, or everybody gets something. Well, this is what we're going to call it. I'm going to call it Oprahing the 3. So we Oprah the 3, A gets a 3, B gets a 3. A times B, the quantity cubed, is A cubed times B cubed. You give out the 3. And this I made, this is me just showing off that I know how to make a fancy box. Ooh, fancy box. So I got a fancy box, A times B to the mth power. A gets an M, B gets an M. Same thing here, A over B to the mth power. A and B both get an M. Woo, that was page 4. I know, we're just jamming right through. Next up, the video, that's the last video of 5.1. Woohoo! Are you guys excited? I'm so excited. Woohoo.